Hello, my name is Cesar Guevara, and in this math project is composed of three members: myself, Marcelo Ramirez-Zablah, and Alejandro Zorrilla. This math problem was based on two given problems given by our teacher, Mr. Bazan. And in the first problem, we have 1A. 1A problem was basically do a piecewise function and answer the following limits that are given. We needed to do a graph and answer the questions. On the second problem, that was number 94, the last one of the lab, we needed to find the equation of the tangent line for the given function, and the same, we needed to graph it to see how it was gonna go. Here, my teammates are gonna explain how to do each problem step by step.
Okay, so problem 94, we have to find the derivative of this formula, this equation, and the tangent line. So first we use the power rule to get the derivative, which we plug in the d over dx formula here, so we get this minus 2, the squared here inside and outside, and the 1 which comes from x, n minus 1, which will be 1 minus 1, 0, and the power rule states that any number to the 0 is 1. So we get the derivative here. After that, we plug in the x, or in this case we get a 2, into the equation to get m, which will be used in I equals mx plus b formula. We plug in 2, we solve the equation, and we get 1/2, which will be the m in our formula. Then, in our step 3, we plug in x once again, but in the original equation. Then we get 5/2 because we do 2 over 2 to the squared, and it gives us 4 plus 2, it's 5/2, and that is our y. And the final step is to use the mx plus b formula and plug in the variables. So we use 5/2 as the y, 1/2 as the m, and x as the 2. 2 as the x. And the b we just have to clear it out. So 5/2 minus 1. The negative 1 comes from the mx plus b the mx plus b part, because m equals 1/2 times 2, that is 1, and we just pass it to the other side to let b alone, and we solve and we get 3/2, and then we use the equation and we have 1/2 x plus 3/2.
Okay, so here we have a piecewise limits function that we have to solve. So first we lay out our problem and we graph our equations. And here we have a parabola, which is white, and it's because it's squared. And we're only using the limits that are less than 1, so we're only using half the parabola. And we're also graphing the x minus 2, which is here, but we're only using values that are above or equal to 1. And the first equation, which is the limit of f of x as it's approaching 1 from the left, so we already know we're going to use this equation because we're only using values that are less than 1, and this one's only using values that are less than 1. So we lay out our problem and we plug in the values for x, and we get that the answer is 2. And it's the same thing for this one. For this one, we're using values that are x as it's approaching 1 from the right, so it's above 1 or equal to. So we're using this one, and we just put in the equation and plug in the x value, which is 1, and we get that the limit of f of x as it's approaching from the right is -1. And the last one, which is we're just finding the normal limit, which is x as it's approaching 1. There is no limit because as you can see in the graph, we don't have a complete limit. It's not continuous, so the limit does not exist.